Hey, welcome to episode 2 of Weekend Sprints. In this episode, we will take the application that we created earlier and then we advance it further and ship it to Azure. So let's get started. First, let's introduce the database. So we're going to use a PostgreSQL database with some books in it. So first of all, I would like to run it locally using a Docker image from the PostgreSQL Docker Hub. So I just launch that and expose the port so I can use my PostgreSQL client to access it from the command line. So there are some instructions available as well. You can take a look closer to it. So we just connected to this instance of the PostgreSQL, which we run locally. Let's create a database. Yes, my database has been created successfully. And we're done with the PostgreSQL setup locally for now. So the instance is up and running. Let's leave it and let's move to the next section, which is the application itself. So the application is a bit advanced comparing to what we did previously. So I first introduced the adapter for Python that we use for the PostgreSQL. So basically, having that adapter in place, we can do the queries of our database. There is a basic model usage instruction. So you get connected using the credentials that you can pass either as a string directly from the application, or it's better to keep it as environment variables. And then I also introduced several routes. So for example, the /books route with the get and post method allows us to either fetch books directly from the database, or also via the post method, we can insert the new book with the title, author, number of pages, and Boolean read or not read in the database. And then the get method can return back the list of books to us. And then the second set of methods that we have over here is the put and delete method. So with the put method, we can update the existing book, and then delete, obviously we can delete the book. All right, so that's clear. So the little step that we have to do as well is to set the environment variables, because in Python application that we are going to run, we have set those variables using the environment variables. So I need to set the host name, the port, the database name, the user, password, and some other parameters that PostgreSQL requires. Okay, so the first one, we want to explore the get method, whether we can get back the books. All right, so there is some problems. Let's fix it. Oh, yes, of course. We need a schema, and we also have to seed some data because we have no tables in our database yet. So let's use that SQL file. So we create a table, and also we seed 3 books in the table. So let's use the client, the PostgreSQL client for that. So when we use the -f flag Python the file, the database will get the information from it and then will restore it. So basically, we restore the dump from the SQL in our database in MyDB. So if we connect to the database right now, to my database, and if we try to query our books, so let's first see if the table has been created. Yes, books are there. And let's query the books table right now. So let's select everything. And we have exactly 3 books that we've added recently. Okay, so for now, the setup of the PostgreSQL, including seeding, is completed. And then we can also see that our API can fetch the data from the database. Cool. Let's check other methods as well. Let's take a look at the Postman with 4 methods that I've created earlier. So the get method to fetch the books is here. So we can see exactly the same information that we saw via browser. So it returns JSON with all the books available. For now, we have 3 books in place. And then let's take a look at other methods as well. So there is also a post method that goes and insert the book in the database. So let's take a look at the method as well. So it has the title, author, number of pages, and read as well. So that's a Boolean, which is either true or false. So let's go back to our Postman. Let's try to add the book here. So we call the slash books, but we call post method, and then we pass the body with some parameters as well. So we also want the content type set to application JSON. So we send the correct request to the server, and if we send it, it replies successfully. So we got the post method successfully done. So for that, we have 200 back from the server. And also, if we try to refresh the get methods to fetch all the books, we can see that there is a book number 4 has been added. All right, cool. Let's explore some other methods that we've prepared as well. So we have a route to update the book. So there is a method put available as well that requires the book ID. So let's take a look if we can use that method as well. So we go back to the Postman, we define the book ID 4, and then in the body, let's define the values that we want to set to this book now. Okay, and let's check if it works. Perfect. So we received 200. We also can see that the book has been updated successfully. We can clearly see that the put method has been received by the server. So let's validate the last piece, which is delete method in our application. Let's see if we can actually delete the book by passing the book ID to the API. So for that, we go back to the Postman. We use the delete book method, and then we pass the book number 4 because that's the book we want to delete. That's the book we recently added, and then we see that the book has gone. We can also see that our server have received all the methods that we were passing. And at this point, we finished the setup of the application. So the next step is to Dockerize this application. So we've got a Docker file from the previous episodes. We're gonna reuse it. All right, let's build the image. Also, I will use the Docker buildix, which is the CLI plugin that extends the Docker commands with the full support of the features provided by the Mobile Builder toolkit. And I do it because I have to define a platform for which I want to build the image. All right, wonderful. We get an image. So let's explore if we can run the application from that Docker image. So for that, I will also do a little change to my Postgres because I want to give a name to my container. So I can also use a network and I can explore via network the DNS of that container. So I can actually do the queries from the application. So for that, I will also introduce network and I connect both containers to that network so they can be in the same network and they can actually do the queries against each other. And I also run the application itself, but I need to define some environment variables like the PostgreSQL host name, the database name, port number, the user password, and the SSL mode. So it's been successfully created and I can see 2 containers up and running. So my last step is to add the Docker network. So for that, I will add it using the CLI and I will connect both containers to that network so they can actually start to work with each other. All right, so let's take a look at the database. Let's actually add the table to the database and let's seed some tables with some data in that database, since we've recreated the instance of the PostgreSQL, and then we didn't use any Docker volumes to store the state of the database, so we have to do it again. So because it's a development environment, that's absolutely fine. So we've got a database with some table in it, and then if we query the database from the Dockerized application now, we can see that it works. All right, so what we've just done, so we have a database running locally, and we have application Dockerized with all the things that we need. So now it's a good time to actually explore how these can be executed in Azure. So for that, we go ahead and first take a look at the images that we've created. So the second piece, as in the previous episode, we've created a Cochlea Azure Container Registry. So it's still there, and we're going to reuse that, and we're going to push the existing application that we keep locally to that container registry. So we need to log in using the Azure CLI. So we've logged in, and then the credentials are stored in my keychain. So as a proof, we can see that there is a Docker config referring to this, and then let's mark this application with the new tag that will point to our remote container registry. So that's going to be cochlea.azure.cr.io / the application name. So we keep it exactly the same up. And finally, let's push it to the remote registry. Okay, the process has been finished successfully. Let's examine the registry itself. Let's make sure that the application is there. So the next is deployment to Azure of this application. So for that, I will take a look at the Bicep templates that I've prepared earlier. So let me actually execute the deployment itself, and then I will walk through the things that will be deployed. So for deployments, I will use AZ deployment group. So the group is a scope to which this particular deployment, as well as resources, will be deployed or will be created. So we pass the group ID or group name, and then we also pass the template file. And then before we do the actual deployment, we do what if. So the deployment contains that KeyVault model, but it's not only KeyVault itself, there are also some other things. So let me define username and password, because these are the required parameters that will be securely stored in my KeyVault. And let's take a look at the model. So the KeyVault contains the reference to the model, and in that model we can see that there is actual KeyVault that contains a configuration, also access policies, and it also has two child resources. So basically the secret that will be deployed to the KeyVault with the name of DB user. So that's why we store the username for my PostgreSQL database. And the second is the password. So it looks like the what if has been successfully validated. So with that green highlights, we can see that it's going to be successfully deployed, and we can also see that resource changes equal 3. So let's define the username and password right here in the CLI command itself. So we use the user for the DB user, and we use the password for the DB password. It will be actually stored in the KeyVault secret slightly different because those $signs have to be escaped. They are special characters, so we need to keep that in mind. So, and while we have this deployment running, let's also take a look at the parameters that we are passing with the -p flag. So I'm actually passing the tenant ID, object ID, because those two things I use in the KeyVault when I define the access policy. So this actually allows a specific user, which is defined with the object ID, within that tenant ID have access with the scope that we define here. So in this case, we give full access to all secrets in this particular instance of the KeyVault to the object ID user from the tenant ID. So that's what that means. Yeah, so there are also a few other things that I want to outline here. So we use a secure decorator for the DB user and DB password, meaning that these are secrets, and we also use some um, special functions like the unique string, for example, which is taken from the location, and this will just generate a random string for us. And also, yeah, we can see that the resource has been successfully created. So we get a key vault in place. And if we go to the key vault, take a look at the secrets, we see that we have two secrets, DB user and DB password. So that's exactly what we provided. So there is also access policy set for the user, and it gives full permissions on this particular instance of the key vault to the specified object ID user, which is myself. All right, let's create some other resources that we need for the application. So we also look at the same folder where we have some other things in place. So in this time, we're going to use the other file that contains some references to the models. And let's actually execute the deployment, and then we will walk through the files that we are going to deploy here. So again, like in the previous time, we used the what if just to examine what will be changed in the infrastructure. So what exact resources we're going to add. We use the scope group, and for that we define the -g we can print as a group. And then we can also provide some additional parameters in line here in the command line because because why not? So for that we define the ACR name, which is the container registry, because we're going to use that in one of our resources. And the second piece that we want to provide here is the reference to the key vault, because we also have references from one of the model. All right, so let's give it a try. So let's validate via what if what will happen if we deploy this template. So let's examine the main Bicep file. So we do have major two things that we want to deploy, which is a PostgreSQL model. So that contains our database information. And the second model is the web app. So that model contains the web application along with some extra resources that we need for the web application. So the PostgreSQL model contains the Azure PostgreSQL resource itself. So we have a bunch of references, including the secrets, and the secrets we actually fetch using the get secrets function of the Bicep directly from the key vault. So for that, we define the existing resource key vault. Let's actually execute the actual deployment, since we have what if successfully validated and says that it's going to be two resources created. And let's examine the template further. So we have the dot get secret function, which will help us to fetch database and username. And then we have also the firewall rules list in array. So this is something that we submit via the parameters, and it contains my IP address, so I can whitelist access for myself using the client from the local from the terminal client for the PostgreSQL, so I can do some changes. All right, and then so the second reference that we have from the main file is basically the web application, and let's examine what exactly in this model we have. So we also pass a bunch of parameters that we would like to introduce to the web app, so the web app can communicate with the PostgreSQL. And then if we take a look closer at this, so the first one, we create a web application service plan. So this is a parent of the web application. It's a Linux type or Linux kinds. And then the actual web application uses that application service plan ID, because it will be created based on its parameters. And then in the web application itself, we also define the Docker image that we want to spin for the application. So we define the reference to the container registry that already has our application. So we recently pushed it there. And we also provide some other things. So for example, we set the environment variables because we need them for our Python application to communicate with the PostgreSQL. So for that, inside the section app settings, we define the what is the port of the application, and also we define the references to the PostgreSQL information. So the other thing that we want to provide here is the Azure Container Registry, and because it needs some sort of authentication in place, so for that we use the managed identity. So first of all, we define the we fetched the existing built-in role, which allows to do the ACR pull. So that's the action to do the actual Docker pull command to be able to execute it. So we do the reference via the UUID, and then we create the actual managed identity, and then after that we do the role assignment to that managed identity on the scope of the ACR, or actually on the scope of the resource group that holds that ACR. So having that in place, we can say that our web application can easily pull image without any authentication. So basically, we don't have to teach our web application to do Docker login or AZ ACR login. So instead, we use managed identity underneath or in the middle, so which will allow us to do these sort of activities. So some other things that we use here. So basically, we use the decorators as previously to make sure that we are passing the secrets like username and password securely from the database to the web application, and we don't really hardcode them to the template or to the parameters. And also we define some other things, like the password over here, and then we define some other things in the model, like where exactly we can find the URL of the PostgreSQL. So this is given by the output from the PostgreSQL model to us, and then in the next model we can also reuse it by referring to the outputs like PostgreSQL outputs and then PostgreSQL name, for example, or we can even get the whole object, and then we can start looking into the attributes of the object. So for example, properties for fully qualifying domain name. We can also fetch the administrator login for the username. So the password is given to us by the get secret function. And yeah, that's pretty much it that we need in the parameters. So we just need to wait a little bit to get our deployment finished, and then we can start working on it. Okay, so our deployment has been finished successfully. Let's take a look at the portal and what exactly have been created. So we have a bunch of things here, and then let's take a look at the deployment. So we have all our models deployed successfully. We have application, we have web application, we have a database, and then let's actually get the server name. Let's try to get connected to that server so we can see that it works, and then we can also add some tables and seed some data to those tables so we can actually get our application working. So with the client, we need to define also the SSL mode to require, because our SQL in Azure is set with the parameter to always use SSL. So we also want to get the password for that database. So it looks like we can successfully log into this database. So let's create a DB or database, my database. And then let's also seed some data as we did previously for the localhost environment. So it works. We've created a table. Let's validate that we have some table created. So let's connect to my DB and let's try to select some books from that table because it's exactly the same. All right, it works. So let's quit for now and let's go back to the portal and let's take a look at the web application configuration. So what exactly is there? So we get this URL, so we can immediately take a look at what is going on there. And while it is still probably pulling the application from the container registry, let's take a look at the configuration that we've set. So we have a host name, the username, port number, username, and also a website port. So this is where the Azure Web Application expects the application to work on. So then if we take a look at the deployment center, so in the deployment center, we have an interesting picture. So we are referring to a single image up with the latest tag, and we use for that the managed identity. So basically we use that role that we defines in the Bicep template. So the built-in role with ACR pull permission. So this will allow us to pull the image from the registry and run the application successfully. So it looks like the application is here. So let's explore some of the paths or some of the routes that we defined in the application itself. So for example, let's check the health the path. So it returns back the I'm fine JSON, meaning that it works. And also let's explore some of the methods that we defined as well. So let's take a look at the books get method. So it returns 3 books that we seeded to the table books. And then let's actually use, let's take a look at the web application itself. Let's get the URL from here and let's take a look at the Postman. So let's examine all 4 methods. So create, remove, update, delete. So CRUD methods, to make sure that the application that we built and deployed to Azure works. So we've added a book from Alinkar. And then if we go back to the get method, so it returns back, meaning that the book is there. And then we can also update the book by defining the book URL. And we, for example, want to update some of the attributes of the book. Yeah, of course, we need to change the base URL for that. And if we submit it, it says successfully submitted. And then if we go back to the get method, so we can see that the book instance has been updated. And then the final piece is delete the book with ID 4. So it looks like it's been deleted successfully as well, meaning that the API that we deploy to web application works successfully, and it actually cooperates with PostgreSQL, which is also in Azure, and we deployed everything with Bicep. Sounds good? All right, so we've deployed a lot of things to Azure. Let's just quickly summarize by going to the main Bicep templates and visualizing this template. So we've deployed web application that hosts our Python backend, and then we have a PostgreSQL database that keeps our data, and then we have also a container registry for the Docker image, and then we have KeyVault that we use for the secrets. Thank you for watching and join me next time.